Have you ever wondered about the origin of the universe? Where do we come from? What is the universe made of? Humankind has formulated this question to themselves thousands of times through the course of history. The insatiable thirst of humankind won't be satisfied until we unravel the mysteries of these questions. What if I tell you we are only one step away from finding these answers? Tonight, I will introduce you to the machine that will lead us to those answers, the Large Hadron Collider. According to the article, What is the Large Hadron Collider Trying to Accomplish?, published on March 10, 2008 by Discovery News, the Large Hadron Collider is the most complex physics experiment ever made by man. It is 27 kilometers of machinery. That's the same length from here, from Mount San Antonio College to Ontario Airport. First, I will give you a brief description about the Large Hadron Collider. Then, I will explain you how it works. And finally, I will tell you the objectives of the Large Hadron Collider. According to the Encyclopedia of Espionage, Intelligence and Security, the Large Hadron Collider is located in the European Organization of Nuclear Research, also known as CERN. The CERN is located in Geneva, Switzerland, and the Large Hadron Collider was built 100 meters on the ground. As I just said before, the Large Hadron Collider is 27 kilometers long, and it crosses the border between Switzerland and France. According to the CERN official website, the Large Hadron Collider cost is $9 billion. That's enough money for paying full tuition for 21 million full-time students at Mount San Antonio College. According to the article, The Overture Begins by Adrian Cho, the Large Hadron Collider started working on September 10, 2008. The article, Having a Blast, Wish You Were Here, also made by the same author, states that the Large Hadron Collider took 20 years to be built. The CERN explained that the Large Hadron Collider is just 27 kilometers of superconducting magnets connected to each other. According to the article, How the Large Hadron Collider Works, Part 2, the Large Hadron Collider is the home of 10,000 supermagnets. A supermagnet is a magnet that conducts energy like really fast. In order to make a magnet to be superconducting, you have to keep it to a temperature of minus 271 degrees Celsius, which is equivalent of 1.7 degrees Fahrenheit. That temperature is even colder than space. To keep that temperature, they use liquid nitrogen and liquid helium. Now you're a bit familiar with the Large Hadron Collider, but you don't know how it works. So I will explain to you how the Large Hadron Collider works. According to the physicist Chris Mann, the Large Hadron Collider is divided in 5 different phases. The first phase is a proton accelerator. It's a hydrogen, which is the simplest atom in the periodic table, is fed to the linear accelerator, and its electrons are fed off, leaving only the protons with positive charge by themselves. Using magnets with positive charge, they pull the protons until they reach 1/3 of the speed of light. The speed of light is 300,000 kilometers per second. That's fast enough to give 7.5 laps to the Earth in 1 second. After they reach that speed, they go to phase 2, which is a ring of 157 meter diameter. In that ring, they also use magnets with positive charge in certain points to speed up the electrons until they reach 91.6% the speed of light. When they reach that speed, they're ready to go to the third phase. The third phase is the electron positron. The electron positron is another ring of 7 kilometers long. On that ring, the protons reach a speed of 99.9 the speed of light, and the point of transition. The point of transition is when a particle cannot go any faster, and instead of gaining speed, it gains weight, because it cannot hold so many energy. It gains so many weight, its energy contained in the proton reached 25 giga-electronvolts. When it reaches 25 giga-electronvolts, they go to the next ring, which is bigger. It's approximately 10 kilometers long. And in that ring, it reaches 450 giga-electronvolts. The last phase is the Large Hadron Collider itself. The Large Hadron Collider itself has 2 rings inside with protons going in opposite direction and have 4 intersections each. In the intersections, they have detectors of collisions, which they use to analyze the crashes between the protons. When a collision is done, scientists analyze them. But what's the point of analyzing a collision? What's the goal of it? Now, I'm going to explain you what are the objectives of the Large Hadron Collider. According to the article, The Search for the Boson Higgs, the Large Hadron Collider is looking for a molecule named the boson Higgs, as I just said. The boson Higgs is elemental for the standard model of physics. The boson Higgs can help the scientists explain how matter interact with each other and explain the origin of the universe. Another objective of the Large Hadron Collider is finding antimatter. As you may imagine, antimatter is the counterpart of matter. It's like adding +1 and -1. They cancel each other. That's why we don't find antimatter in this world. The contrary of an electron is a positron. The contrary of a proton is an antiproton. If we were to find matter in the world and we were to touch it, we would disappear, and a huge blast of energy would happen. Also, the Large Hadron Collider will help us explain why is the matter dominant over the antimatter in the universe. The last objective of the Large Hadron Collider is finding different dimensions. Say the string theory says that if high power atoms crash at high speeds, different dimensions may be detected. Now you know what's the point of using the Large Hadron Collider, which is finding the CERN. And the Large Hadron Collider will finally unravel those mysteries all humankind has been looking since the beginning of time. So I hope you are now interested in it, because maybe when we get home, those mysteries will be unraveled already.